Hey guys, we're going to continue here with Chapter 5. We're going to be talking about the standard form. So here we're going to add another intercept. It says the x-intercept is the x-coordinate of a point where a graph crosses the x-axis. That's kind of intuitive if you know what a y-intercept is. The standard form of a linear equation is ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. All right, meaning at least one of them can't be 0. The other thing is, oftentimes it's not written in this. It says that they're real numbers, but typically when you see standard form, a lot of times you see it written as integers. It doesn't have to necessarily be integers to be standard form, but we do see that often. And so I just want you to be aware that a lot of the problems we're going to be looking at today are going to say, write it in standard form using integers. All right, let's keep going here. Yes, this is a real thing, and yes, I may be buying this for Christmas to adorn myself. Yeah, look at that. Beard ornaments. What's that guy looking at? All right, so finding x and y intercepts, it says, what are the x and y intercepts of the graph? 3x plus 4y equals 24. If you recall a y-intercept, the y-intercept is when the x-coordinate is 0. All right, so to find this, you just make x 0. This is very, very simple. So I have 3 times 0 plus 4y equals 24. Well, notice here that anytime any number is times 0, it makes that particular number go away, or in other words, it multiplies out to 0. So here I have 0 plus 4y, which is just 4y. I'm going to just ignore that and divide both sides by 4 and solve for y. All right, so y equals 6, which this is the y-intercept. Okay, so 6 is the y-intercept. And then to find the x-intercept, you do the exact same thing, except the x-intercept, if I think of a ordered or a coordinate plane, the x-intercept, when it crosses this line, is when this value is 0. When y is 0 is the x-intercept. So we'd say the x-intercept is when y is 0. So we could do the same thing here, and I have 3x plus 4 times 0 equals 24. And since we know multiplying by 0 eliminates a number, I'll just go ahead and ignore that and divide by 3, and I get x equals 8. So this is my x-intercept. X-intercept is 8. Now something here that's kind of a shortcut, or something that you notice very, very quickly here, is that to find the x-intercept, you ignore this and then solve for x. So divide that by 24. To find the y-intercept, you ignore this and solve for y. In other words, the y-intercept when you solve is y equals. The x-intercept when you solve is x equals. It lays it out for you so that you could remember, did I solve for x? Oh, yes, I did. That must be the x-intercept, or vice versa for the y. So that's kind of a nice way to look at this, just to help you remember what's what. So here's one for you to try. The answers will be up in 3, 2, 1. So there you go. That's what I got for the intercepts. So check yours against that. Be careful. This has to be -10 because you're dividing by -6. So make sure you're paying attention to that. Pretty simple stuff. All right, so graphing a line using intercepts. So to do this, we just identify our x and y intercepts. So the y-intercept on this, we're going to divide -2 by -2, is 1. And then the x-intercept for this is x equals -2, because the y is 0. So x equals -2. So to graph a line using these, I just plot these two y-intercepts. So the y-intercept here is 1. So go to that, and then the x-intercept, it crosses this line at -2. I'm going to use a different color because I've been seeing that this is difficult for you guys to see. Let's do that and that. All right, so from this point, I could see a slope. I could use that to find other points to make it easier to graph. You don't have to do this. You could just draw it straight from that point, but I do it because I don't have a straight edge. And that's what it looks like right there. So using the y and x intercepts to draw a graph, you just find where those 2 points are and then you connect them. So here's fun for you to try. Go ahead and give that a go. The answer will be up in 3, 2, 1. All right, so your graph should look something like this, going through the y-intercept here and this. If your graph is not big enough, remember you could go up by intervals of 2. You are allowed to change your intervals. You just need to make sure that you point that out at some point. All right, so here is another one to take a look at. It says, what is the graph of each equation? When it is x equals 3, that means that all of the x values are 3. So that is a vertical line, and this shouldn't be new to you, but there it is. So this is x equals 3. And when it's y equals, that is a horizontal line. All right, so that's y equals 3. So how does that blue look on there? Hey, that's not bad. I like the yellow better. So x, when it's x equals, is vertical. Wait, yeah, vertical. And when it's y equals, that is a horizontal line. So make note of that because that's going to come up. All right, so transforming to standard form. Remember, standard form is the ax plus by equals c. And notice here it says using integers. So the first thing that I need to do with this is to get rid of that fraction. This is going back to when you add or subtract fractions and you're trying to find that LCM. You have to find the denominator and eliminate it by multiplying by whatever the least common multiple is of all of the denominators. Well, this one only has one denominator, so it makes it really, really simple, which means I'm going to multiply everything by that value. So I have 7 times this, and then 7 times all of this. So 7 times y is just 7y equals, this gets distributed. So I have -3/7 times 7 is just -3. And then I keep the x. And then plus 35. And then I want it in this form, which means I need to get this over here. So I'm going to add 3x to both sides. And when I add 3x to both sides, I get 3x plus 7y equals 35. And there is my equation written in standard form using integers. All right, so here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, so this is what I got. This is not the only way to do this. I'm not even going to say it's the most efficient way to do this. It's just the way that I did it. So first thing was get rid of these parentheses by distributive property. Then I wanted to start getting the x and y over here and the other values or the constants over here. So I added 2 to both sides, which got rid of my constant. Then I wanted my x and y on the same side. So -1/3 x plus 1/3 x equals 0. All right, it's not nothing. It's 0, which is an integer. Okay, then from there I need to multiply it by 3 to get rid of my fraction. And so I get x plus 3y equals 0. So that is that one written in standard form. That's a tough problem, but it's not impossible. So take some time and look at that if you are unclear as to what all that means. All right, so using standard form as a model, it says a media download store sells songs for $1 each and movies for $12 each. You have $60 to spend. Write and graph an equation that describes the items you could purchase, and then what are 3 combinations and number of songs and movies you could purchase. So here, we're going to have 2 things. We have songs and movies. So songs are $1 plus $12 for movies. and we have $60 to spend. So the price of songs, or the amount of money that we spend on songs, plus the amount of money we spend on movies, added together must equal 60. All right, it could actually equal less, but we'll work with inequalities later. For now, we're just going to say must equal 60. All right, so in order to do this, here's our equation. In order to graph it, let's find our x and y intercepts. So here we'll call this songs, and this we'll call movies. And let's find where it would intersect here. So as weird as it sounds, the s-intercept is 60. We could get up to 60 songs. The m, or the movie intercept, how many movies at most we could get if we spent all of our money on that, would be 5. All right, so number of movies, because this is only increasing by 5, we'll go ahead and just number it like this. I have 1, 2, 3, 4, and 5. Okay, so there are our movies represented. For songs, it's a little different because we're going up to 60. All right, so I have a pretty decent amount of spots here. So let's see if I'll have enough here. If I go 10, 20, 30, 40, 50. Yep. All right, so we'll make each block worth 5. And I use these intercepts. So this intercept is right here. This intercept is right here. And then I connect the two of them. Now, if you had a straight edge, what you're interested for is where it says, what are 3 combinations of number of songs and movies you could purchase? You're interested for when this crosses this line perfectly. Okay, so that is the different things that you're interested in, and really it should cross kind of perfectly around these 4s. Like you could get 4 movies and then the rest in songs and so on. So some different combinations we could get. You could get what this is, 5 movies, 0 songs. You could get what this is, 0 movies, 60 songs. Or you could get something in the middle, all right? And this is where we're kind of looking at what these different values are. So here I could do, if I did like 3 movies, here you're going to have to use a little bit of math, but 3 movies looks like it's not quite the 30. It's somewhere in between these two. This is actually off. My graph isn't straight, so I have to use a little bit of math. If I did 3 movies, that's 3 times 12. Is 36, which leaves me with 24 songs to get up to the $60 that I have. Okay, so you could do 3 movies and 24 songs. You could do a lot of different things here. You could have done 1 movie and 48 songs. All these different values would have worked, but here's 3 of them right there. You're only asked for 3. All right, so here's kind of a final concept summary for the different lines. This is all of them. So here's our slope-intercept form, point-slope form, and then the standard form, and how all of them work. This is all the same line. Okay, so negative 2/3 x plus 6 in point-slope form would be this, and standard form would be this. And this is the way they look when they graph. They would all create the same graph. They all have different usefulness in different situations. So this is a good thing to probably have copied down into your notebook. Noticing that, first of all, that this equation has 3 different ways we could write it, which are all represented here, but it has a single graph to it. I believe that's it. All right.